That was a pretty epic intro. Maybe a little too epic. Anyways, my name is Ashwin Bala, and I will be explaining the obtain speech function. The obtain speech function takes a URL input and returns the text on that web page. First, we use the built-in URL read function to get the HTML code from the URL link. The text we want is between two specific HTML tags. We use the regular expression function to find the indices of these HTML tags, and then extract the text within these indices. We now have the text, but there are various HTML tags within the text, such as bracket P's and bracket I's. We then find the indices of these tags using regular expressions once again, and then replace these tags with spaces. Once we have only the text from the web page, the obtain speech function returns this as an output.
Hello, my name is Cameron Moy. I put on some Old Spice just for this video. So after we had our function that obtained a State of the Union speech from a URL, we needed to create a database with all the speeches of all the presidents. Essentially, what Kaleb and I did was create a separate vector for each president that contained all State of the Union speeches for that president, as you can see in the code. Then what we did was create a 43-row cell array and place George Washington's vector in the first row, John Adams' vector in the second row, and so on and so forth until we had our complete database, which we then named President Directory and saved as a .mat file. This way, when searching the speeches of a particular president, we only needed to search one row rather than search multiple indices for each speech. Another advantage of doing this is that our GUI doesn't require internet access because we are able to save presidentdirectory.mat and include it in our program file.
It's me again. I will now be explaining the search engine function. This function takes two inputs. One is the speech string that it will be searching, and the second is the phrase the user inputted. The search engine actually has two ways of operating, depending on whether the user input is 1 gram or more than 1 gram. It calls upon the gram counter function to determine this. Gram counter simply counts the number of spaces in a string and then adds 1 to this count. If the user input is more than 1 gram, the search engine modifies the user input with possible endings, i.e. spaces, commas, etc., as well as possible beginnings, which include a space before the expression or a double hyphen. We then use the regular expression function to find this modified phrase within the speech. Counting the number of indices will give us the number of appearances of the particular expression. Now, if the user input is 1 gram, the search engine will similarly modify the phrase with possible endings and beginnings. It will then find the indices of all the spaces in the speech. Using a for loop, the function obtains the text from the speech that appears between two space indices, and then uses regular expression to see if the user input appears in this region. The reason there are two methods of execution for search engine is because the first method does not account for repeats of two single gram words in a row, such as that. However, both of these methods fail to account for when the user input is the start of the speech, because there's no space before the start of a string. So at the end of search engine, the function modifies the user input with all possible endings, but not all possible beginnings. Using regular expressions once again, we will find the appearances of this modified phrase in the speech. And then there's an if statement that checks whether this phrase is the beginning of the speech. If it is, we add 1 to the appearances count. If not, there's no need to change the appearances count. The search engine then returns the number of appearances of a phrase within a particular speech.
It smells like Old Spice in here. Did Cameron put on Old Spice just for this video? Hi, my name is Kaleb Klauber, and I worked mainly on creating the GUI. So as we approached making the GUI, we thought first about how to make the interface the sleekest and most user-friendly as possible. The elements we needed to incorporate were an edit text box so the user can input a word or phrase to search, some sort of menu to select a president, and thirdly, a push button to command the program to run. Also, we needed a static text box to spit out the number of times the search item appears. The possibly most robust part of this menu would be the list of all the presidents, with 43 different presidents to choose from and one extra option to select all presidents. In order to make the interface nice and concise, we decided to put all the presidents in what MATLAB calls a pop-up menu, but really it's more like a list box that has a scrolling menu. Now that you know the design process of our GUI, it's time to explain how it actually works. Let's take a quick look at the GUI first. Damn, that is a nice looking GUI, if I may say so myself. So the user first enters a word or phrase, selects a president, and then presses search. Under the pop-up menu function, the program determines the selected item and saves the string, which is the name of a president, as a variable named A. It makes this variable global so the program can reference the string later within the search button function. So the user presses search and a few things happen. It loads the president directory, it brings the global variable A, I talked about before, into this function. Also, it initializes two global variables called final and user input, which I'll explain further. Okay, so we get the user's input string from the text box and define it as the variable user input. Then we use an if-then statement for every president. We use string compare to determine if the global string A from the pop-up menu matches a president's name. If it matches, then it uses the custom function search_engine2 to find how many times user input appears in the president's corresponding row. This number is defined as the variable final. Finally, it converts final to a string and sets this to the static box on the user interface. Now I'm going to turn it over to Cameron to explain when the user chooses to search all presidents.
Me again. So if the user selects all presidents, the variable final is set as a string for a histogram, which is then displayed in the output box. Next, our GUI creates an empty 43-row matrix of zeros called phrase appear, and then runs a loop from 1 to the length of president directory, which is 43 times. Each time it searches each row for the phrase that the user inputs, counts the number of times that phrase appears, and then saves that number into phrase appear. This takes about a minute to run, so we took the liberty of programming an fprintf to display processing in the command window, so please don't Control-C before it's done. After saving all of our outputs into phrase appear, I then used my custom function called bargraph, which takes an input matrix and graphs it, with the x-axis being the president and the y-axis being the number of times the input phrase appears. And then our GUI displays the histogram. Please amuse yourself by searching the State of the Union speeches for the most random phrases you can think of. Enjoy!
Now we're going to look at a demo.
So here's our code for a GUI, and when we run this program, our GUI pops up. So here is our edit text box for the input phrase. Here's our pop-up menu with all the presidents and an option for all presidents. Here's our search button, and then here's our output box. So let's search all of George Washington's speeches for the word country. So as you can see, country appears 12 times in George Washington's speeches. Now let's change the president to, say, John Tyler, without changing the input phrase. Alright, so the word country appears 79 times in John Tyler's speeches. And let's change this to change and search for President Obama. And okay, so the word change appears 27 times in Obama's speech. And now let's do all presidents. And as you can see, it displays refer to histogram in the output box and displays processing in the command window. Alright, so here we are about a minute later, and you can see our histogram, so displaying the number of times change appears in all the president's speeches. And that's the end of our demo.
We then use the regular expression function to find this modified phrase within the speech. Counting the number of indices.
Okay, let's stop.